Today we will study electrical power consumption in star and delta connected network. So the star and delta connected network load could be a three-phase induction motor, three-phase resistance bank, reactance bank, generator, and transformer. In our industry and commercial load, various types of networks are connected in star as well as delta. So based on that, we see how to calculate the power in star connected load and in delta connected load. For this, some of the consideration need to be taken while calculating the load in both the networks. So the first consideration is that the line voltage VL is same for the star connected as well as delta connected network, and the load impedance, that is ZPH, it will combine the resistance and inductance of the load is same for the star and delta networks. Now the calculating power consumption for the star connected load. In this figure we see that the star connected network, like that. In this, the RYB phase and RYB windings, here in between the R and Y phase, this is the line voltage, that is VRY, same for the remaining phases, and the line connected, that the line current, that is IR, and same line current flow through the R phase winding, that is IRPH. That means the IR and IRPH, that is line current of R phase and phase current of R phase, is a same. But here we see that the line voltage of R phase, that is the VRY, but the line voltage of R phase, that is VRPH. So based on this we can say that, as shown in figure, we can find the following relationships. So the line current IL is equal to IPH, that is the line current IR, same flow through the R phase winding. So the line current IR is equal to I phase, that means the line current of IR is equal to the line current of equal to the line phase current. Same for the line voltage. The line voltage, we see, we in this diagram we see that the line voltage VRY is not equal to VR phase. So the line voltage VL is equal to root 3 times VPH. That means the R phase voltage is equal to root 3 times VRY. For example, here, for example, that is IR equal to IRPH, that is the phase current, and VRY, that is the line voltage, is equal to root 3 time phase voltage of R phase. So for that, the power calculation for the star connected network can be calculated as, so the P star, that means the power of star connected load, we can find root 3 VPH IPS cos 5 PH. That means the phase voltage, phase current, and power factor. Based on that, we can replace the IPH based on the Ohm's law, that is the IPH equal to VPH by ZPH. We considering that ZPH for the star connected load as well as delta connected load is the same characteristics. So putting the IPH value, that is IPH value, into the equation 1, so the P star 3 phase equal to this value we are putting here. So the VPH upon ZPH into cos phi is, therefore the P star connected, based on that, the 3 VPH square cos phi PH upon ZPH. So we know that the line voltage and phase voltage relation in the star connected load, that is the VPH is VL by root 3. From here, from the star connected load, that is, this is the line voltage and this is the phase voltage. So the phase voltage is equal to root 3 time VPH. From this equation 2, we get this equation, that is P star equal to, that is power in star connected load, equal to 3 VL by root 3 square. We put this value in this equation, that is this value in this equation, we get this equation. So here we simplify the equation and we get final of the equation is that P star is equal to VL square cos phi upon ZPH. Here is the, we consider that the ZPH constant for both the load, that is the same magnitude of ZPH, hence the cos phi of both the star and delta connected load is the same, so we keep it constant. Hence we say that the power consumption in star connected load is VL square by ZPH. ZPH is the actually impedance of this winding, that is this winding of R phase winding impedance, and voltage across this, that means this voltage square upon the impedance of this winding, it is the power calculation of star connected load. So we go for the delta connection load. Power calculation for delta connected load, consider same formula. Here we see from this diagram we can see there VRY is the phase voltage, same for the Y and B phase, but here we compare star and delta connected diagram, we found that one basic difference is that this is the R phase current is split into the two phases, that is R and B phase. Here the R phase current is equal to the phase current, but here is the line current of R phase is not equal to the phase current of R phase. From this we can find a relation that the line voltage is equal to the phase voltages, that means the VRY is equal to the V phase voltage of the same winding. Here VRY same getting to this winding VRY, but the current is split into the two branches, so the line current is equal to root 3 times of phase current. This is the two relations we need to keep in mind while calculating the power of the delta connected. Same for the, as we calculate for star connection, same here we also consider that the IPH is equal to VPH upon ZPH, that is the simple Ohm's law. By putting this value in equation 3, so we get that the power of delta 3 VPH into this value we put in by replacing the current, so VPH upon ZPH. By from this equation we get 3 into VPH square cos PH upon ZPH. So same for the delta, we know that the line voltage and the phase voltage relation in delta connected load, that is VPH equal to VL. Here we see that this is the line voltage and is equal to the phase voltage, so this value we put in this equation 4. By putting this value in equation 4 we get the 3 VL square cos phi PH. So here also the cos phi PH is the same for the delta connected, so we kept it constant. So the power consumption in delta connection load is the 3 VL square by ZPH, and power connection in star connected load we calculate in last slide, that is power calculation in star connected load is the VL, that is line voltage square upon ZPH. So from this equation 5 and 6 we can say that the delta connected load power is equal to 3 times of star connected load. So based on this we can see that the delta connected load can be produce a 3 times greater mechanical power if it is the motor, and same for the other if it is the load bank, it will consume the 3 times more power in case of delta connected load. But from the diagram we see that the delta connected load, this winding facing a voltage is equal to the line voltage. If we consider that line voltage is 415 volt, 415 volt, then 415 volt actually 415 volt come across the R phase winding. So the insulation of the delta connected winding should be greater than the star connected winding. So from this conclusion we can say that the delta connected network consume 3 times more power than the star connected load. Thank you.